Okay, so once we've checked that we're ready to program, this is how we're going to get started. So we're writing our very first program in RobotC. Now how we're going to approach this is that we're going to go piece of hardware by piece of hardware. So rather than focusing on the programming language itself, we're going to learn the programming language as we focus on each piece of Vex hardware, okay, which is I've found is the best way to do it. All right. So the very first thing we're going to do is open a RobotC file. So we're going to go ahead and click, I'm going to ignore these buttons right here for now, and we're just going to go File, Open and Compile. Oops, sorry, not File, Open, Compile, File, New, and New File. Okay, and what we get here is we get a source file, and we're going to immediately save it. So File, Save As. I'm just going to save it on my I have a folder where I'm putting everything, so we're going to save. We're going to save this as Vex Shop. And we're going to call it 1 Motors. Okay, and we're going to click Save. Okay, so that's saved. Now let's take a look at what's in here to start. It's very simple, right? So what we have here is we have a task called main. So main is the name, task is what it is. Okay, so a task is kind of like a function or a method in other programming languages, except that tasks are managed a little bit differently by RobotC. Tasks, you can basically, it allows you to control tasks that are simultaneous running. You can think of task as a thread, interestingly enough. So tasks can run simultaneously with other tasks, whereas functions run one after the other inside of a task. But we don't have to worry about that right now, okay? All you should worry about right now is that we have a task called main, okay? And when a RobotC program runs, it looks for the task called main and it runs whatever in there first. Okay, so it just opens up the program and runs any code inside the task main. Okay. Now, a task is a function, for our purposes, is a function. And a function is just a block of code. Okay, and a block of code means a set of lines of code which are between two curly braces in this case. Let me go ahead and do the font increase here so we can see it a little better. Okay, so on line 3 we have a curly brace, and on line 7 we have a curly brace. Okay, so all the code that's in task main is between those two curly braces. For the time being, don't delete the curly brace on task 3, or on line 3. Don't delete the curly brace on line 7. And only put code between those two curly braces. Curly braces are kind of like twins. You never have one without the other. Okay, you never have an opening curly brace without a closing one. Same thing with parentheses. You never have an opening parentheses without a closing one. Okay, so basically don't do anything to this file except for add code between the two curly braces, between this curly brace and the other one. All right. The next thing we're going to do is, in order for us to control hardware with the Vex Cortex, we have to add a motor and sensor setup. And all this is a mapping between what is physically attached to the Cortex and our program. If you've written in other programming languages, you really don't have this. So in another programming language, you don't have physical stuff you're trying to control, so you don't have to map it into the program. But with the RobotC, we do. So we're going to go ahead and click Motors and Sensors Setup. And then, because we're only doing one motor today, okay, we're going to click on the Motors tab, and we're going to give our motor a name, okay? Now, there are a couple things you need to be aware of. I'm going to go ahead and type left and then motor. Okay, now I know it's not left motor, but it gives me a little bit to talk to you about, okay? You'll notice that I put left is lowercase, motor is uppercase. That's a way we're all going to write our variable names like that and our names for our physical devices. And what this is called camel case. It's a way that programmers name variables. And how you do it is you name like, for example, the motors. This should reflect where they are on the physical robot. So if the motor's on the left, call it left motor. If it's on the right, call it right motor. If it's on an arm, call it arm motor. Okay? It should reflect the physical setup of the robot that you're writing. Okay? The second thing is that when we use camel case, we're using the first word in the name is lowercase and the rest of the words are uppercase. That way when we read it, we can quickly read all the different words that are contained in it. Otherwise, it just looks like a bunch of smushed up letters. Okay? So in this case, left motor, lowercase left, uppercase motor. Also in RobotC, we don't want to just use very simple names like the word motor. It would make sense in this case. It's only one motor, so it makes sense just to use a lowercase motor. What can happen in RobotC is if we name our variables or devices words that conflict with words that are already in use in RobotC, it can cause problems in our program. So we want to at least use two words, like left motor, right motor, something like that, okay? Also, please be aware that you need to use this, when we reference this motor in our program, you have to use exactly the same letters, and that includes using upper or lower case. So left motor here would not be the same as typing left motor with a lowercase m, okay? RobotC, like other programming languages, is case sensitive. So we have to use, if we use an uppercase M here, when we reference the name in our program, we have to use an uppercase M there. Okay, so it's what's called case sensitive. So an uppercase M, not the same as a lowercase m. Okay? All right, the next thing we're going to do, after we get our name down right, we're going to select the type of motor. This is on the back of whatever motor you're using. So whatever motor you've plugged into your Vex Cortex, on the back of it in white writing, it should say whatever motor it is. In our case, it's Vex 393 motor. We're not going to worry about the rest of the stuff. We're just going to go ahead and click OK. All right, so what happened here is that RobotC automatically wrote this line of code. And you'll notice that it starts with a Pragma statement. Okay, so for each of the devices that you set up, you'll have one line that starts with Pragma, okay? And you should not edit any of this, all right? So it's written automatically for you. You can go in and edit it, but there's no reason to. If you want to edit it, if you double click it, it will just open back up into motors and sensors setup, okay? So if I double click this line, it opens back up. It's easy to edit it. And I just click OK. All right, so our motors and sensors setup is, motors and sensors are set up. In our case, it's just one motor for our first program. The next thing we're going to do is we're going to start to add code into task main. The way that we're going to do this to start out is we're going to drag and drop. Programming is not like writing an essay, okay? You don't have to type everything out. In fact, the more you type, the more you just free type, the more you're going to type wrong letters, you're going to get errors inside your typing. So as a programmer, you want to copy and paste as much as possible. You want to drag and drop as much as possible. You want to use autocomplete as much as possible, okay? Because every time you type, it's possible that you can just by clicking the wrong key, you can get the wrong letter combination, and it can cause bugs in your program, okay? All right, so what we're going to do is we're going to drag and drop. So all we're going to do for this program is we're going to start the motor, we're going to wait, and we're going to stop the motor. That's 3 lines of code, okay? So we're going to open up we're going to open up natural language. A lot of the stuff we're going to do is going to be in natural language, okay? And notice that if I haven't, under platform type, if I haven't checked natural language, notice that it's not present. So if you don't see natural language on the left here, you have to go to Robot, Platform Type, and choose natural language, okay? So we're going to open up natural language, we're going to open up movement, and we're going to drag over start motor. Notice that when I mouse over start motor, it gives me this help. See, start a motor at specific speed, range -127 to 127. Okay? Just be aware that that's there. Okay, next we're going to go ahead and drag over wait, and then we're going to drag over stop motor. Inside of the parentheses on each one of these lines, you'll notice that this is the name of the function in blue. Okay, so and then inside the parentheses after it are the parameters. Okay, so these are the things, motor port and speed, that we have to feed into start motor in order for it to work. So even though it says motor port, we're going to write the name of our motor. And notice that, see how it comes up? It automatically select it. If I arrow down here and hit enter, it'll automatically type for me. Okay, that's a great way to do it, because that way I can tell whether RobotC is recognizing it. Now sometimes it will glitch and it won't appear there right after you put it into your motor and sensor setup, but a lot of times it will. Okay, so we typed in our name of our motor. Our speed is going to be 127. We know that because we highlighted, we can mouse over the command and we can get that range, -127 to 127. Negative just means it's in reverse. So 0 to 127 is forward at some speed. 0 to -127 is reverse at some speed. Wait time is in seconds. I know that because I can highlight over the command, right? It says it's in seconds. We're going to wait 10 seconds, and then we're going to change the motor port to left motor again. Okay, arrow down, enter to autocomplete. All right, so that is our first program. The next thing we're going to do, and the final step in all of this, is that we're going to compile and download to the robot. So this, what we're working on right here, is what's called a source file. This is a human readable file. When we compile, it's going to compile into machine code, an executable machine code file. Okay. Now it's not going to be anything we can read, but it can be read by the cortex. All right. So it's another process. Compile program just compiles it. See, I click compile and it said, oh, there it is, compiled on whatever the date is. Okay. I can also click download to robot. What download to robot does is it compiles it first and then sends the compiled version down to the cortex. It also puts me into debug mode. So you'll notice that you're in debug mode when this debug window comes up. And then you can go ahead and start the program. So I've downloaded to the cortex. Now I can click start. Okay, and I can click stop again. All right, so basically when I click start, you should hear your motor go. That's how you'll know that it's working. Mine's disconnected, so it's not running. The other thing that we can do here is that we can go to, and what I would like, when you're running your first program, please do this, go to Robot, Debugger Windows, click on Motors, and click on Debugger Windows, and click on Sensors. And you'll notice down at the bottom here, we can click Motors with PID. Notice that any motor that we defined here, if you look at the power, when we click Start, you'll see it go to 127. So we can see in the debugger window what the program thinks it's putting out to the motor. It's very, very, very helpful. Okay, that's how you write your first program and download the robot. Best of luck.